Hi, everyone. So it's been a while, but luckily the semester's coming to an end. So give me 1 second and we'll share my screen. Here we go. And so my presentation is going to be on chemical defenses in sessile organisms. And so I'm going to mostly go into the organisms that they're going to be corals and sponges. Those are just because if I went into all chemical defenses in all sessile organisms, it would be a lot longer than the time span that we currently have. Okay, and so here, so to go into this, we're going to have to talk a little bit about corals. So just to clarify with everyone that corals are animals, not plants, and many corals build or are a part of reefs, and these corals are called scalactinians. Many reef-building corals have a symbiotic relationship with zooxanthellae. And so to go into this, we're going to have to also talk about requirements for a reef and for corals to survive, and that's going to be sunlight. We're going to need water currents, which will allow nutrients to come into the area, and so, and lastly, it's going to be space. So you need space for larvae to metamorphosize into polyps, and most importantly, the space has to be on a hard substrate. It can't be really like soft, or else it just won't take. Now, because of that, space is a limiting factor because you need hard substrate in fairly shallow waters, and you're going to need good, and it's going to have to be in a place with fairly strong currents. So because of this, you're going to have many different species, like sponges, that also want that space. And this means that corals are in constant competition with other species. So competition is a major part of reef life. It comes with wanting to get in that gray area. Now, because of this, you're going to have a couple of tools in your tool belt, as they like to say. So you're going to have, you might have things such as like tentacles that can reach out. You might be able to grow really quickly, but what we're going to focus on are chemical defenses. And so these are going to be chemical compounds that are used. They can be against other organisms to prevent them from eating you, or you can enhance competition where you can take over more territory. And so a couple of the different animals that this would be used against would be fishes. Some fish species consume coral, so they'll try to eat coral, and any chemical defenses will protect against that. You'll have sponges that try to come in and take over the area, and it'll try to kill off corals. You'll have your macroalgae. You'll have they try to come in and they try to block out the sunlight, and they try to kind of like smother corals. You'll have your soft corals, because in the case that we're talking about reef-building corals, you're talking about hard corals, and so soft corals aren't as common in reef building. And then you'll have ascidians and corallimorpharians. And so the other group that we're going to be talking about when it comes to this are sponges. So sponges are filter feeders, and sponges and corals share many of the same needs and habitats, and so they're in almost, because they share those same needs and same habitats, they usually live around each other. And so they're in that constant competition with each other to try to take over areas. says that some sponges will produce allelochemicals, and studies support that there is a metabolic cost for producing these chemical defenses, and that they're going to have slower growth, and it's going to be a longer process for them to heal if they get hurt. And so what we're going to be talking about are some of the benefits. So what are these benefits of creating and then having to store these toxins when you have to divert energy into doing that? And one of them is microbial resistance. So you have, so over on the right here, I have a picture of palytoxin and palytoxin, and these are found in a sponge called Amphimedon viridis. Okay, and in Amphimedon viridis, you're going to have certain bacteria and algae, stuff like that, that will try to come in and try to kill the sponge and cause it to die off. But palytoxin and amphitoxin target those specific microbes that come in that would otherwise kill the sponge. But the interesting thing about it is it is not, it won't kill everything. It's very specific because there's certain bacteria that need to live on that sponge that are actually beneficial to that sponge. So the sponge wants to keep those on, and that's why it has this kind of very targeted defense system. And so another kind of benefit are being able to wound your competitors, being able to stop competitors from coming in. So you have those allelochemicals that we talked about earlier, and they're found in your soft corals, your sponges, and your ascidians. And so if you wound competitors, they have to take that time to regrow what was ever hurt or destroyed. And so that decreases the growth of the competitor and makes it take them longer to come back into your territory. And so what we're going to be talking about is, again, on the right is this yellow sponge. It's called a Stephanodictyon, okay? And so it's a sponge that actually tries to go into the territory of coral. And in the case of this, what it'll try to do is it'll try to go under the coral and over, and it'll try to kind of erode at the coral over time and outcompete it, and hopefully in the course of the sponge it will try to kill it. And so one of the things it does is it sends out these allelochemicals that kind of cover the coral, because it's like a mucus, and it'll cover the coral and it'll prevent the coral from growing, and it'll prevent the coral from respiring, so it won't be able to gain that energy to really kind of fight it off. Because like we said earlier, also, these defense mechanisms, they require this kind of energy. And so that's a way that these sponges can really kill off these other corals. And so in the case of this one, on the same idea, you have this Diploria labyrinthiformis. Okay, in this case, it's targeted by Caribbean sponges. And these Caribbean sponges will try to wound it, and they'll try to take down their foe system too, which is where a lot of organisms will get their energy from. So you can probably see what a common theme is, wound it and try to take away this energy and stuff like that. And in the case of this Diploria labyrinthiformis, is kind of on the wrong side. This is the one that is having these chemical defense systems used against it. And then, but on a good note for corals, this is actually at the same time how they can escape these sponges, so they can release those chemicals and just kind of hurt the sponges, and then they grow away from them. So they try, if they start growing in the opposite direction, then it becomes a game of really just catch up for these sponges. And so it could be beneficial for corals to have these defense systems. And so one of the last benefits is that corals can have, and sponges actually, so these chemical defenses, specifically, the research that I was able to read was specifically in sponges. I didn't see a lot of this in corals actually, were these anti-fouling properties, where you're going to have these larvae that come in due to after like breeding season, stuff like that, and they're going to try to come into the substrate that you in the area that you live in, and it's going to, the purpose of these chemical defenses is to prevent them from moving in. You kill the larvae while they're still in the water and prevent them from getting into that area. And so one of the things that is an anthropogenic disturbance, one of the things that can change because these are such complex processes, you have competition, you have predation, you have, and these defense systems, it's actually eutrophication. And so these corals rely on other organisms to have a limited number of resources as well. So these corals can live in areas with high water turbulence, low, they're very shallow water, stuff like that, but they don't want a whole ton of an influx of the nutrients that come from runoff, like your nitrogen and phosphorus that coming into your rivers and coastal waters, because that allows these hermetic mollusks, your ascidians and your corallimorpharians, to outcompete with these corals, and they just won't be able to survive. And when you're coming back into this, you're thinking of, well, you have these other species now that come in and have taken over, become the dominant groups in that area, and it's also going to become an issue, especially with those chemical defenses that can kill off larvae, for larvae of corals to come back into that area and be able to become part of the ecosystem again. And so how do these chemical defenses, how do they affect humans? And so I actually did a separate presentation on this before, and it's on this thing called palytoxin. So palytoxin is one of the most potent toxins known to humankind. It can be inhaled, it can be ingested, it can even be absorbed through your skin. And an important part of this is that heat doesn't change it. So you can see the chemical formula on your right, but and a lot of times heat will break bonds in chemical compounds, but it doesn't do it for this. And so that's a really important aspect of that. And so we're coming close to the end of this presentation. And so I just wanted to put in some time for the site of works. So you can see my name here at the bottom. That's because of my earlier presentation. But if any of you are interested in corals, sponges, but specifically corals, there's Dr. Pollock that works and does a lot of research at UNCW, and he works a lot with corals. And so if that's something that you're interested in, you might want to reach out to him and see if you can do research with his lab. But so anyways, here we are back in the beginning. But all right then. Okay. Well, I hope you guys do well and have a good rest of your day.